of gases in liquid, solubility of gas in liquids. Okay, solubility of gas in liquids mainly depends on pressure and temperature. We know that many gases dissolve in water. Most of the gases dissolve in water. For example, oxygen dissolves in water. This oxygen will help to survive the aquatic organisms. It is a main important role for the aquatic organisms. On other hand, HCl, which is hydrochloric acid, which is highly soluble in water. The solubility of gases mainly increases with the increase of a pressure. This solubility of gases increases with the increase in the pressure. Okay. Do experiment to understand the phenomena of solubility of gases in liquids. Okay. Consider this system as shown in figure A. This is a figure A. Consider this system. We are going to take a chamber. This is a chamber. Okay, here the lower part is solution. This part is solution. This part is solution, and the upper part is gaseous system. This is a upper part is a gaseous system at pressure P and temperature T. At pressure P and temperature T. Okay. Here, let us assume this system to be in a state of a dynamic equilibrium. Let us assume this system is present in the dynamic equilibrium. Now, what is equilibrium? Equilibrium is the condition where the rate of gaseous particles entering and leaving the solution phase is same. Here the gaseous particles enter and leave. This rate is same. This type of solution is called as dynamic equilibrium, where the rate of gaseous particles entering and leaving the solution phase is same. Now what you have to do is, now increase the pressure over the solution phase by compressing gas to smaller volume. Here we have a frictionless piston. This is a frictionless piston. Now put weight in it. When you put weight here, that is W1, when you put weight, there will be increase in the pressure by compressing. When you compress this piston here, there will be compression taking place, which will lead the gas to a smaller volume. Now notice this figure B. Okay, when you notice this here we have put again two more weights extra to again decrease the volume, W2 and W3. This will increase the number of gaseous particles. Again there will be the increase in the gaseous particle. Look here, there are some gaseous particles, but here there are many gaseous particles per unit volume over the solution. And also the rate at which the gaseous particles are striking the surface of solution to enter it. Okay, the solubility of gas will increase when a new equilibrium is reached, resulting in an increase in the pressure of the gas above the solution, and thus the solubility increases. How the solubility increases? Solubility increases when you increases the pressure. When you increase the pressure here, the solubility of gases increases. Who was the first person to give a quantitative relationship between pressure and the solubility of a gas? Okay, Henry was the first person. Who? Henry was the first person to give the relationship between the pressure and solubility of gas. So now we are understanding the solubility of gas in liquid. We call this type of experiment as Henry's law. We will understand what does Henry's law state. Of gas in liquids. Now here solute is gas. Here the solute is gas and solvent is liquid. Solute is gas and solvent is liquid. The solubility of gas in liquid is increased by increasing the pressure of gas. I have already told you that solubility of gas is mainly increased by increasing the pressure of gas. Now we will understand what is Henry's law of solubility. At a constant temperature, the solubility of gas in liquid is directly proportional to the partial pressure of the gas above the surface of the liquid or solution. Okay. Now think why this partial pressure have been introduced. Dalton. We know that who is Dalton. Dalton is a contemporary of Henry. Contemporary refers means at the same time. When Henry stated the Henry's law, at the same time Dalton also concluded independently that the solubility of a gas in a liquid solution is a function of a partial pressure of the gas. We know that Dalton was the person who studied only about pressure of the partial pressure of the gas. He said that solubility of gas in a liquid solution is a function of a partial pressure of the gas. So by when Dalton said this statement, Henry also used this statement in his law. That is, at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas on the surface of the liquid or solution. Henry's law of solubility, another statement which is also same. At a constant temperature, the partial pressure of gas of the vapor pressure is proportional to the mole fraction of the gas of the solution. It is directly proportional to the mole fraction. What is mole fraction? Number of moles. That is number of particles, can be atoms, molecules or ion. It is partial pressure is directly proportional to the mole fraction. We denote the partial pressure by P and the mole fraction by X. Here partial pressure is directly proportional to the this is the directly proportional symbol. P is directly proportional to X. When we remove this proportionality constant, we get KH. KH is a Henry's law constant. P is equal to KHX. KH is Henry's law constant. Okay. If a gas obeys Henry's law, the plot of mole fraction of a gas in a solution against partial pressure of a gas should give a straight line. When you plot a graph between partial pressure of gas and a mole fraction of a gas, you will get the straight line passing from the origin. This is a straight line passing from the origin. Here KH is a function of a nature of a gas. Okay. Higher the value of KH at a given temperature, the lower the solubility of gas in a liquid. When the value of KH is high, at a given temperature, the lower will be solubility. KH, when the KH value increases as there is an increase in temperature. Therefore, solubility of gas in liquid decreases with increase in a temperature. Similarly, solubility of gas in a liquid decreases with of Henry's law. There are several applications present in Henry's law. First one is to increase the solubility of carbon dioxide in soft drinks. The bottle is sealed under high pressure. Cold drinks manufacturing industries mainly use this Henry's law. They use Henry's law for their solubility of carbon dioxide. When you bring a cold drink from market, when you open the cap of a bottle, you hear the sound like piss. You hear this sound. Hearing this sound is formed. Cold drink manufacturing industries seal the cap very tightly so that pressure is maintained inside the bottle. So the solubility of carbon dioxide in soft drinks, the bottle is sealed in under high pressure. Second point, mountain climbers and people living in high altitudes face with a condition called as anoxia. At higher altitudes, as pressure decreases, the concentration of oxygen in the atmospheric air also decreases. This causes the low concentration of oxygen in blood. As a result, people feel weak and are unable to think properly. At a higher altitudes, means at higher places like mountains, etc., there will be the the partial pressure will be decreasing. So there will be the concentration of the oxygen in the atmosphere will be very less. So they will suffer from the disease called as anoxia. This will cause the decrease in the blood, oxygen in the blood. As a result, the people will feel weak and are unable to think properly. Scuba divers. Who are scuba divers? Have you watched the movie called as Zindagi Na Milegi Dobara? When those three people go to Spain, where Katrina will teach to them how to drive the scuba. Scuba diving is a mode of underwater diving where the driver uses self-contained underwater breathing apparatus. It is underwater diving. must adjust with a high concentration of dissolved gases while breathing in air at high pressure underwater. Increased pressure increases the solubility of atmospheric gases in blood. What happens? The scuba divers will adjust with a high concentration of dissolved gas while breathing air under a high pressure. Increased pressure, we know that as the pressure increases, solubility also increases. When the divers come towards the surface, the pressure decreases. As they go towards the surface of the water, the pressure will be decreasing. This releases dissolved gas and leads to the form of action of bubbles of N2 in the blood. This will make to release the nitrogen in the blood. This blocks capillaries and causes bends. To avoid bends as well as high concentration of N2 in the blood, the tanks used by divers are filled with the air diluted with helium. So to stop this block the capillaries and cause to stop this blends, we must use the high concentration of N2 in the blood. In the blood, tanks used by divers are filled with the air diluted with the